In this video, I am going to go through one very basic example to show you 3 different ways that you could use to solve a trig equation over a given interval. And then you can choose for yourself which method you really want to use. And sometimes you may want to use one method for solving and then another one for checking. So anyway, so this is the example. We're going to solve for x given this particular domain, so it's between 0 and 2 pi, and we are told by the question that psi x equal to 1 over root 2. Okay, so let's just start with method 1. It doesn't matter which method you use, you always need to start by identifying the base angle. So this will never change, so I need to identify the base angle. The base angle is essentially the angle that has a psi value of 1 over root 2, and the only way to identify the base angle is you need to memorize your exact values. So if you don't memorize your exact values, you cannot solve these equations by hand at all. So just keep that in mind. Anyway, the base angle in this case, and I'm going to call the base angle theta. The base angle is pi on 4. And the reason for that is because if I put psi of pi on 4 into the CAS calculator, I'm going to get 1 over root 2. Also written as root 2 on 2 depending on whether you rationalize the denominator. Okay, so that's the base angle, step 1. And step 2, and so the first method, I guess, is when you just look at quadrant symmetry, which is, I think, the method that I tend to teach for year 11 students. So the second step is just to look at this, and this psi value is positive, and psi is going to be positive in the first and the second quadrants based on this acronym. So A means that all 3 trig ratios are positive in the first quadrant, only psi is positive in the second quadrant, only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. So psi is positive, which means that we're looking at the first and the second quadrant. So first and second. And you're going to have 2 answers actually within this domain. So the first answer, which is the first quadrant answer, is going to be pi on 4. And the second quadrant answer, so you do need to understand how to go from the first to the second quadrant, and it is going to be 3 pi on 4. So you only have 2 answers within 1 unit circle. So that's method 1, which is just using quadrant. Now method 2 is actually very similar to method 1, with the exception of, well, the only difference is that I'm going to draw an entire unit circle out and not just rely on this acronym. So the magic of technology, because trust me, if I try to draw a unit circle using this writing pad, you're not even gonna get something that circular. Okay, so method 2, and I do like method 2 and then eventually method 3 because I think it actually highlights a little bit more clearly what is it that you're doing when you solve for a trigonometric function. And exactly what you're doing is you're finding an angle. You're finding an angle that has this psi value of 1 over root 2. So we're still going to start with the same step 1. So the base angle, theta, is pi on 4. And what does that mean? So pi on 4 is like 45 degrees. I underestimate that I still have to draw this. I forgot. Okay, I'm going to leave it at that. So let's say this is theta, which is 45 pi on 4 or 45 degrees. The psi value on the unit circle is the y coordinate. Oh, this is going to be tricky. Okay, I'm going to try to do a vertical line here. That's not going well. It's top-notch entertainment right there. Alright, should have done a different color, but whatever. So this part, which is the y coordinate of this point, is going to be 1 over root 2. Okay, so essentially when you're solving for x, you're finding an angle that when you draw the angle, it's going to cut the unit circle at a point with a y coordinate of 1 over root 2. And I think when you draw the unit circle, you can see the symmetry a lot more clearly than when you just looked at the acronyms. Because if I draw a line on this side, and this is not, again, not going to go well. I need a more expensive writing pad that works better. What even is that? Okay, let's not do that. Let's try one more time. I will apologize, but nope. You know what? That's not too bad. So if you draw a line here, this point is going to have the same y coordinate as this point. So this is also 1 over root 2. And if you want to know what the angle is, you have to connect. Oh, this is going to be tricky. You have to connect this point to the origin. Oh my god. I don't think I can even do this probably on the whiteboard because, you know. Yeah. Again, quality entertainment. Oh my. Can I do this at all? This video is going to be like 25 minutes long and 15 minutes will be you watching me trying to draw and fail at drawing lines. This is not working. Okay. Let's just assume that this is going to go in there. Oh, okay. We're going to stop now. So if you this is so bad. If you connect the dot to the origin, essentially what you need to work out is whatever this angle is. So the way that you read an angle from the unit circles, you start from the positive x-axis and then you go anti-clockwise. So basically this angle, and because of symmetry, if this is pi on 4, this is also pi on 4, which means that this angle must be 3 pi on 4, so they can add up to pi or 180 degree. So using the unit circle method, you can also see that there are two solutions to this question. You have x equal to pi on 4 and 3 pi on 4. But I do think that it gives you a clearer understanding of symmetry, and sometimes students have issue finding out exactly what the second quadrant angle is, but when you draw the unit circle you can really tell what it is. And the reason why there are only two solutions is because you're only going between 0 and 2 pi. So this is another advantage of the unit circle method, is 0 and 2 pi is just going one circle in this direction. So obviously you can see clearly that these are the only two solutions that I can have within one cycle or 2 pi. So that's method 2. Method 3, sometimes it's very useful. Most of the times, I mean, you be the judge of whether it's useful or not, actually. You're going to be the judge of whether I can draw a psi graph, which the answer is no. So method 3 is essentially using the graph, the psi graph, the basic untransformed psi graph. I could do that, but I couldn't connect the dots. Okay, moment of truth. That's not too good. Okay, whatever. So this is a psi graph between 0 and 2 pi. Actually, this bit's gonna drive me insane. And that's pi. So again, what we are doing when we're solving is you are given the y coordinate and you need to find the x coordinate. But the x coordinate in this graph is the angle. It's not this x. So they are different x. Okay. So 1 over root 2, I don't know, that's 1, I know that much. So 1 over root 2 is going to be, okay, somewhere a little bit bigger than, well, it is definitely bigger than a half. Okay, so let's say it's here. So if that's the y value, so the good thing about the graph method is that you can always tell how many solutions you're going to have, because if I draw this line of y equal to 1 over root 2, it's going to cut the graph twice, so you're going to have two solutions. And the first one is this one, which is pi on 4. So the way to work out what the second one is you can again think of symmetry, because this is a beautiful graph because it's so symmetrical, even though I'm not drawing it properly. So if that's pi on 2, because halfway through, and that's pi on 4, that's this bit is also pi on 4, that particular distance, which means that this point is going to be 3 pi on 4. Okay, so you should still be able to tell, and you after these 2 points, because that's where the line y equal to 1 over root 2 cuts the graph, and you can still see from the graph that there are 2 solutions at pi on 4 and 3 pi on 4. So 3 methods. I do think the unit circle one's probably the best one in terms of giving you a visual understanding of what is going on, but the graph is not too bad as well. So don't just settle for one method, especially if you don't like it. Even if you like it, you really want to know what else is out there. And I think a true mark of a true understanding of solving trig functions is if you understand all 3 methods, regardless of whether or not you want to use it. Okay, I'm going to stop now.